Non-functional characteristics and NFT testing of container applications. Abstract container applications are complex in nature as they are a collection of microservices running in sync to achieve the application's desired functionality. This application build structure makes the non-functional characteristics of the container applications more relevant and a focus area of testing for the application. In this paper, the authors have tried to investigate all the possible non-functional areas of container-based application. The paper further delves into the nuances of non-functional testing in general, which would become an integral part of the non-functional testing, NFT, of container-based applications. Keywords: containers, non-functional characteristics, testing, non-functional testing, NFT. Introduction. Application development has now been transitioning to container-based architecture from virtual machines. This is because of several advantages that a container brings in comparison to a virtual machine. 1. This transition is taking at a fast pace and the architectural change is phenomenal, which brings to the fore the overall application's behavior apart from just the functional part. The functional part of any applications remains constant on any architecture, be it traditional hardware, cloud, virtualization, or containers. What changes with change in architecture is the surrounding environment, infrastructure, etc., and the characteristic these changes makes an impact on, is termed and categorized as non-functional aspect of application. This change makes it imperative on part of the software or application developers to have extra focus on non-functional testing of the container-based applications. Functional testing of any application refers to the feature set of the application that it intends to provide to the end user of the application. Irrespective of the platform, environment, or other external variables, these feature sets or the functional part of the application remains constant. To illustrate it with an example, a railway reservation application's primary functionality of booking tickets remains constant irrespective of whether the application is mobile, cloud, or traditional. This stands true for all applications, and thus the intended functionality is always rigorously tested, and it is a continuous process where even after the application is in production we see number of new releases which could include patches to fix existing bugs, application supporting new functionality. Non-functional testing of any application encapsulates several external and behavioral parameters and traits of an application. Contrary to functional behavior, non-functional behavior of an application fluctuates and changes depending upon the platform, environment, and other external variables around which the application is built upon. Taking similar example of the railway reservation application, the non-functional behavior is bound to change based on the surrounding ecosystem it is built upon. 2. Related work. A. Containers. Containers are referred to as packaging units of applications that are built using the concepts of microservices. Container can also be related to virtualization, which extends the concept of virtualization to OS level, whereas normal virtualization aims at virtualizing hardware resources. Several characteristic and definition of container along with difference between containers and VM are elaborately defined in 1. B. Application testing. Application testing is an integral part of any software or application. Without proper and complete application testing it cannot be made live or deployed for production. Broadly, application testing can be categorized in two different branches of functional testing, where the functionality of the application is tested thoroughly, and the other being non-functional testing, where the application is put under test because of the surrounding environment and its behavior with respect to changes in these characteristics. See non-functional testing. Non-functional testing, NFT, is a collective term given to test various non-function traits and parameters of any application. In 3, the author of the article has very effectively and in detail defined various non-functional attributes, methodology to test these attributes, comparison between functional and non-functional testing, and the importance of non-functional testing. DY containers and its applications. Non-functional testing. Adaptation of container-based application has been growing at an aggressive speed because of its benefits over cloud and traditional applications. Containers development methodology is based on microservices architecture, which is complex but adaptable and more manageable when compared to the traditional monolithic applications. David 5 suggests 3 best practices to test and evaluate performance of any container-based application. I. Service-oriented approach. 2. Testing services independently, and 3. Right-size container performance testing. Joe 4 has done an extensive research about the growth of containers over the years since 2015 and have predicted its growth path till 2020. He estimates the container market to grow around 40% on a yearly basis. Non-functional testing of container-based applications is to extend the NFT to container-based applications. Container-based applications being a fairly new and a fast-growing concept which aimed at better life cycle management and performance of application without utilizing much of resources. Thus, important characteristics needs to be tested thoroughly for such applications to be successful. 3. Proposed work. In this work, the authors intend to propose the non-functional attributes and characteristics of the container-based applications that should be an integral part of any such applications. Each non-functional characteristic's relevance will be discussed and presented to bring forth its relevance in the overall testing of the application. A. Non-functional characteristics. Below are the proposed non-functional characteristics that should be mandatorily tested for all container applications. 1. Scalability and performance. Scalability testing refers to the expansion, scale up, and contraction, scale down, of the application as per the real-time traffic. This ensures that the application uses optimum resource and thus helps the provider to use its hardware resources more efficiently without affecting the application's runtime. Another byproduct or extension of scalability testing is performance testing. While testing applications for scalability, it is deemed that the application's performance also be tested with respect to the following. A. End user experience of the application. Under stress or load. B. Limit of application vis-a-vis resources allocated or in short capacity of the application. 2. Stability and robustness. The criteria set forward to measure the stability of an application is the length or time duration of the application uptime when the application is put through stress, load, and different environments. Robustness testing is an extension of stability where the criteria measured for robustness is to test the application's strength under different load and stress scenarios. This measures that the application is not behaving abruptly when put under duress and responses of the application are as per expectation. 3. High availability and geo-redundancy. High availability, HA, refers to the application's availability irrespective of system, hardware, or any other resource or site failure. It makes sure that the application is redundant in such a way that failure of application instances because of any external reasons does not impact the availability of the application. In simplistic terms, HA can also be defined as a property where the application does not have a single point of failure. Canso et. al. 2 in their article have in detail examined the various HA mechanisms with limitations. Geo-redundancy of an application refers to the application's availability when an entire data center or a cloud environment where the application is hosted goes down because of any reasons like power outage, natural calamity, etc. The below diagram presents a basic view of the HA and geo-redundant architecture of a container-based application environment. The diagram is simplistic in nature as it hides the complexity of several components involved in container and its orchestrator. It also abstracts the integration flow between the components. B. Testing strategy. Our testing approach that has been formulated for the NFT of container-based applications comprises of 5 primary steps. Each step is executed for every non-functional characteristic that is being tested. 1. Build environment. Testing environment needs to be prepared that suits the characteristic under test. All prerequisite to execute the intended test suite must be proactively analyzed and implemented in this phase. 2. Define test cases. It is expected that there would be a list of predefined test cases to be mandatorily executed. Apart from this list, test cases for the characteristic needs to be prepared with expected results in conjunction with the application under test. 3. Execute test cases. Execute the case for the application and observe behavior. Each approved test case from the previous step needs to be executed by confirming its pre- and post-test case execution criteria. The results need to be documented post-completion of the test case. 4. Collated results and logs. Result of test case executed should be compared with expected result defined against each case. Collect all relevant logs related to the case which needs to be analyzed as part of testing procedure for any interim errors or warnings. This should be documented with possible workarounds and mitigation. 5. Analyze logs and certify application. Thoroughly analyze all logs to conclude the behavior of application in toto. A certification criterion should be generated which based on the complexity of the test cases and their results would certify the application into several categories. For conclusion. Container-based applications are new and rapidly growing which makes the developers vulnerable to resist the mere building blocks of the application. There should be special focus on the non-functional aspect of container-based application because the performance, stability, and robustness of the application is dependent on the environment it is hosted. With containers the underlying environment and hardware is completely abstracted and thus it is extremely important for container application developers to keep the non-functional characteristic of container-based application a priority, right from the design phase. The proposed non-functional characteristics are primary building blocks of container-based applications. Before going production ready it is advised for any container-based application to test these non-functional characteristics. Proposed testing strategy would also help in streamlining the life cycle of testing where each test cycle for every non-functional characteristic will result into analysis of the outcome of the test. The proposed overall approach of testing and analyzing will help in enhancing the quality, stability,